there's a section in our book about text mining, and we're going to talk about some of the ideas from this section in the context of an example in Python. But before we jump into that, we need to discuss another method for classifying data. So we're going to talk about a classification method that's designed for a binary response variable. And we're going to talk about something called logistic regression that you may or may not have heard about before. And just as a caveat, this class is mostly about descriptive analytics and data visualization. And in this example, we're going to veer a little bit into the realm of predictive analytics. But I think it's helpful to think about and see kind of a different way of classifying data. So logistic regression is a classification method, again, designed for a binary response variable. So something where there are two options. And we're going to think about our two options being 0 or 1. So some examples here are maybe a company has a lot of customer reviews and they want to be able to quickly categorize these reviews as either positive or negative. So positive might be a 1, negative might be a 0. Or maybe an organization wants to look at factors that influence whether or not someone is going to renew their membership. So renew their membership might be a 1, does not renew might be a 0. And you might want to predict if a movie is going to be profitable. So profitable would be 1 and not profitable would be a 0. Another example is maybe a bank wants to be able to predict if a customer will default on a loan, maybe based on the balance of the loan. So 1 would be the customer defaults and 0 would be they don't. And so the response variables are either 0 or 1, but we want to use other information to predict if we're going to get a 0 or a 1. So this example shown here, the horizontal axis is showing the loan balance. So we have the loan balance for a lot of customers. And then we have data on whether or not that customer defaulted on that loan. And so we can kind of notice a trend, like with the bigger loan balances, we had more people default, but maybe for somewhere, in between, we might want to be able to predict if someone is going to default or not. And in the past, in previous classes, you've seen linear regression. So you've fit a line to some data, but here that wouldn't be a good option. And so I want you to maybe pause for a minute and think about why linear regression wouldn't be a good idea here. And this picture might be helpful. So here our vertical axis is the probability of default. So probability is 0 if they don't default, and it's 1 if they do default. But if I did linear regression, the line could take on any value. Could be negative values, could be values bigger than 1, whereas probabilities should only be between 0 and 1. And so what I would really like to have is a function like this blue curved function here that's always between 0 and 1. And maybe I have some cutoff. So here there's a cutoff that looks like it's around 0.5. And if I have a loan balance that gives me a point on that blue curve that's above that cutoff, maybe I would predict that they do default. And if I have a point that's below that cutoff, I would predict they don't default. And so I would really want that curve. And so here I've included kind of some work that we could do, some algebra to get that curve. And so the idea is, if we were doing linear regression, we might have started with a p on the left-hand side, but probabilities can only be between 0 and 1, and the line, this beta naught plus beta 1x, could be any number, any positive or negative number. And so we could divide by 1 minus p, take the logarithm, and then if we take the logarithm of p over 1 minus p, that can be any number. And so at the top here is really the equation that we'd want. And I don't want you to worry about how we'd solve this for p. I've included the steps on the slide, and we could go ahead and solve this for p, do a whole bunch of algebra. And if we did that, we would get this function shown on the right here. So p of x is 1 over e to the minus beta naught plus beta 1x plus 1. And so I just want us to see what this looks like, what this function looks like. And so there's a link and a QR code here just so that we can see what this looks like. So here is what we would have if we look at that link. And so this is what that function looks like. And depending on what the beta naught and beta 1 are, it shifts and looks a little bit different. But this is the type of shape that our function has. Oh, there we go. And so this looks like the sort of thing we wanted that's always between 0 and 1. So that's great. So this function really does have the right shape. In general, we could have more than just one x variable. We could have, here there are p x variables. We could have a bunch of different x's that we want to use to make predictions. And our function would have this same form. We would just be in more than 2 dimensions. And the assumptions that we'd need to make in general are that these x's are independent, no multicollinearity, linearity between the independent variables and log odds, and a large sample size. I don't want you to worry about all of these details here, but I want to show you how we can use Python to make predictions using logistic regression, even though, like I said, this is veering a little bit outside of the realm of just descriptive data analytics. I think it's helpful to see, to get kind of a taste of the types of things that you can do. And so next, we're going to use logistic regression to actually classify product reviews as either positive or negative using the link or QR code here.